Today we're going to talk about chapter 7.4 in your textbook. We're going to talk about exponential functions and the graphs of them. The form of an exponential function is y is equal to, or f of x is equal to b to the x. This value b is going to be a number. The x is the variable. So when you have the variable up in the exponent, which is something different than what we've ever graphed before, it's called an exponential function. This b value must be positive, not equal to 1. If b is greater than 1, like if b is 2 or 3, if this is 2 to the x, 3 to the x, 4 to the x, then the function increases or goes up. The graph is going to look like this. It goes up. But if b is less than 1, but still positive, that means b is a fraction or a decimal, like b is a half to the x, or 1/3 to the x, or 3/4 to the x. Anything less than 1 but still positive, the function decreases or goes down. And so now our instructions are to graph y is equal to 2 to the x for all integral values. Integral means an integer between -3 and 3. So to graph anything with a y and x variable, you're going to just set up a table of values, and the x values start at -3, and they're going to go all the way up to +3. So we'll just evaluate this. We'll just plug in -3, -2, -1, 0, 1, 2, and 3 into y equals 2 to the x. And then we'll graph those points and talk about the graph. Y is equal to 2 to the -3. 2 to the -3 is 1 over 2 to the third, which is 1/8. So the first point on our graph is x equals -3 and y equals 1/8, which is really close to the x-axis. The second point, y is equal to 2 to the -2, is 1 over 2 to the +2, and 1 over 2 squared is 1/4. So we'll graph the next point, which is -2, comma 1/4, which is just a little bit up from the x-axis. The next one is -1. 2 to the -1 is 1 over 2 to the first, which is a half. So -1 comma half will come up here. 2 to the 0, anything to the 0 is 1. So 0 comma 1 is the next point on the graph. 2 to the first is 2. 1 comma 2 is the next point. 2 to the 2 is 4, and 2 comma 4 is the next point. And then 2 to the third is 8. 3 comma 8 would be the last point on this graph. So here is a nice smooth graph that is called y equals 2 to the x. Please label that. The domain on this particular function, well, this domain is actually going between x is -3 to 3, but the domain normally of an exponential graph is all real numbers, but just in this particular case, because we're starting and stopping here, we have x is equal to -3 all the way up to 3. The range of this particular graph, the y values go between 1/8, the smallest number, and 8, which is the biggest number. Now there's something called an asymptote. I think we talked about an asymptote once before with a graph that we did earlier. But an asymptote is a line that a graph will get closer and closer and closer to as x gets really small or really big. So there's an asymptote here, which we always draw as a dotted line. The x-axis is the asymptote, and the equation of the x-axis is y is equal to 0. So this asymptote is the line that y is equal to 2x gets closer and closer to, but doesn't touch. As x goes all the way back to -infinity. If you get x smaller and smaller, this graph will get closer and closer and closer and closer and closer to that x-axis, but it will never touch it. Now what we're going to do is we're going to graph y is equal to a half to the x power. So this function should be decreasing because this base is less than 1, like we said earlier before. So we're going to again let the x values go from -3 to 3. And now we're going to take 1/2 up to those powers. So 1/2 up to the -3 power. Well, because it's got a negative exponent, you flip the fraction. 1 over 2 becomes 2 over 1. And the -3 becomes a +3. And 2 to the third is 8. So I want you to graph this on the same grid. What I'm going to do is I'm going to get a different color and graph this one in red. So -3, 8 will be the first point on this graph up here in quadrant 2. And then 1/2 to the -2. Flip the 1/2 upside down, it becomes 2 to the +2, and 2 to the 2 is 4. And I'll put all those points on the graph all at once. 1/2 to the -1, flip it upside down, and negative becomes positive. 2 to the first is 2. Anything to the 0 power is always equal to 1. 1/2 to the 1 is a half. 1/2 squared, a half times a half is a fourth. And 1/2 to the third power, 1 cubed is 1 and 2 cubed is 8. So now we have some x and y values. If I'm going too fast, make sure you just pause this video and you can just zoom in, or you can just take a look at this. Whoops, I guess I'm a little bit off here. There you go. So those are the x, y values that we're going to put on the graph up here above. So we've already put 3, 8 down. The next one is -2. I'm sorry, -3, 8. The next one is -2, 4. The next one is -1, 2. The next point is 0, 1. 1, comma, a half. 2, comma, 1/4. And 3, comma, 1/8. So this other graph is curving around like this. And this we need to label as y is equal to 1/2 to the x power. Make sure if you have two graphs on the same grid that you label each of them with their equation. What is the relationship between these two graphs? If you take a close look at them, you can see that this red graph is reflected, or this has been reflected through the y-axis. So the relationship is they are reflections of each other through the y-axis. I don't know why I'm writing this in red. What is the common point between the two graphs? Well, the common point is where they intersect, and they intersect right here at point 0, 1. Why would this point 0, 1 be the common point of any graph? Y equals b to the x? Well, if I had y equals 3 to the x, y equals 4 to the x, y equals 5 to the x, they're all going to go through this point right here, 0, 1. And that's because when x equals 0, b to the 0 is equal to 1. So when x equals 0, y will always be equal to 1 no matter what the b value is. So anything to the 0 power is equal to 1. You would have y is equal to b to the 0 power. So when x is equal to 0, this exponent, when x is equal to 0, then y is equal to 1, and 0, 1 would be the point on any graph, no matter what the b value is. So 0, 1 is on all exponential graphs, as long as they haven't been shifted up or down or right or left. So here's a question. Did you know that y to the half x is the same thing as y equals negative 2 to the x? Think about that for a minute. Why is this true? Well, if you have a negative exponent, remember the base flips upside down. This 2 has like an invisible 1 here. So if you have 2 over 1 to the negative x, 2 to the negative x power is the same thing as 1 over 2 to the x power. And 1 over 2 to the x power can also be written as 1 over 2 to the x power, because this 1 to the x and 2 to the x. So what transformation occurs between 2 to the x and 2 to the negative x? Well, right here, this equation, this graph that we just drew was 1/2 to the x power, but this also could be called y is equal to 2 to the negative x, because 2 to the negative x is the same thing as 1/2 to the x. Same exact thing. So what transformation occurs? Well, when you negate the x, when this x becomes a negative x, if you negate the x, you reflect to the y-axis. I should say the graph. If you negate the y's, it reflects to the x-axis. All right, so you can't see that. So here you go. If you negate the x, the graph reflects to the y-axis. Now we'll go over to this next page and finish up the day's lecture. So now what we're going to do is we're going to sketch the graph of y equals 1/4 to the x. And then we're going to graph y equals x plus 5. And then we're going to see where these two graphs will intersect each other. We're going to find the value of x where they intersect. So let's do our xy table on y equals 1/4 to the x power. Let's let x go from -2 to +2 this time. 1/4 to the -2 power is equal to 4 to the +2 power, which is 16. 1/4 to the -1 power is 4 over 1 to the positive. 1/4 to the 0 power, anything to the 0 power is 1. 1/4 to the 1 is 1/4. And 1/4 squared is 1/16. So our table of values says -216 would be our first point. -1/4 is our second point. Every graph exponentially goes through 0, 1, 1 1/4, and 2 1/16. So here's the graph of y equals 1/4 to the x. In red, I'm going to graph y equals x plus 5. So y equals x plus 5, set up some x and y values. We'll go from -2 to 2 like we did here, -2, -1, 0, 1, and 2. And y equals x plus 5, -2 plus 5 is 3, -1 plus 5 is 4, 0 plus 5 is 5, x plus 5 is 6, x plus 5 is 7. So now we have some points that we can plot. Y is equal to x plus 5. Let's see, -2, 3, -1, 4, 0, 5, 1, 6, and 2, 7. So this is a graph that will just be a straight line going through here. And what is the value of x which satisfies that equation when this equation is equal to this equation? This x value is x equals -1. on your own. We're going to graph 2 to the x, 3 to the x, 4 to the x on the same set of axes below. So I'm going to show you a little trick or a little something that would make this go faster. If you could grab your graphing calculators. Oops, I'll get a different one here. And what we're going to do is we're going to put these in our graphing calculators one at a time. Y is equal to 2 to the power of x. And let's look at the table of values. We had these same 0.125 is the same thing as 1/8, 1/4, 1/2, and 1. So 2 to the x has these values, and we'll just plot those here. -3, 1/8, -2, 1/4, -1/2, 0, 1. Oh, this is counting by 4s, by the way. These tick marks are each x equals 4. So 1, 2, 2, 4, 3, 8, and 2 to the 4th is 16. 2 to the 5th is 32, and 2 to the 6th is 64. If you want to look at the table of values here, you can just take a look. 6, 64 would be one of those points. So here in black, I'm going to put arrows on the end because these graphs really keep going. I didn't tell you what the domain was. So this one is y is equal to 2 to the x power. Now let's take our calculator and put y is equal to 3 to the x power. Take a look at that table of values. So we have little decimal values here when x gets negative. And then we have bigger values over here when x goes from 1 up to 5. And we have 4, 81, which would be too big to graph on our graph paper. So we'd really have to stop at 327. So again, we have decimal values here. I'm going to do y equals 2 to the x in my black pen. I'm going to do 3 to the x in my red pen. So 1, 3 would be a little bit above here. 2, 9 would be up here. 3, 27. Let's see, that's 28. 27 is a little bit below that. And 4, 81 would really just be way off this chart, way up here. So this red graph starts off going below the black graph. They go through the common point 0, 1. And then it just keeps getting steeper and steeper like this. So this is y is equal to 3 to the x. And let's see if I can find another color. Let me do it in green. Y equals 4 to the x. So I'm going to just take a look at 4 to the x, the table of values. So these are even smaller values of y here when x goes from -1 to -3. And then you have 0, 1, 1, 4, 2, 16, and 3, 64. And that would be the last point we could graph because 4, 2, 56 would just be too big. So these points over here, you really can't see much of a difference because of the scale. It still goes to the same value on the y-axis. And 1, 4, 2, 16, 3, 64, because 4 to the 3rd is 64, and that's as far as we can go because 4 goes up to 256, and that's off from our graph. So this last one right here is very steep. This is y equals 4 to the x, so I'm doing that in green. What is the domain? Well, we have arrows on the ends of all these, so the domain is x is all real numbers, all of those x values, because x can go all the way down to the negative, most negative, and it actually goes to the right forever. But the range, the y values, y could never be equal to 0 because it will never touch this. Let's label this dotted line. Dotted line, the asymptote is y equals 0, which is the x-axis. So none of these graphs are ever going to touch this x-axis. That's why we put it as a dotted line. It'll get closer and closer and closer to it, but it won't touch. So the range, the y values are always greater than 0. It'll never go negative. The asymptote is the x-axis, or y equals 0. And compare these three graphs. Well, what can we say about the comparison of the three graphs? Think about that for just a second. What's the difference between the black graph, the red graph, and the green graph? Well, one thing that's the same is 0, 1 is on all three graphs. The larger the base, the base goes from 2 to 3 to 4, the larger the base, the steeper the graph. And then the last thing that we can compare it to is all three graphs are increasing because all three bases are greater than 1. So here's one comparison, here's two comparisons. All three graphs are increasing. And you might be able to think of some other similarities between them. They all have the same asymptote, y equals 0. All exponential functions. Looks like they all go up very, very quickly. But that's it for today, and tomorrow we'll get some, on Monday we'll get some practice for this.